Solving inequalities. Your calculator can actually help you solve various inequalities. And if we start with example 1 here, one of the things we can do is we can graph both sides of this inequality in the same way we were graphing both sides of a quadratic equation. And then we can look for places where the left-hand expression is higher or above the right-hand expression in the graph. Let's see what that looks like. So if we press the y equals button here, and I'm going to clear out the last two graphs. I'm going to press the clear button, and I'm going to cursor down and press the clear button again, and then I'll cursor back up to y1. I'm going to put in the left-hand side of the equation, negative 6, and that's just going to graph as a horizontal line. And then I'll put in the right-hand side of the equation, 4 plus 5x. So here we go, 4 plus 5x. And press enter again. And then I can go ahead and graph that. I'm going to start with a standard window. So I'm going to press zoom and choose option 6. And we'll see what we get here. So the calculator graphs what was in y1 first. That's negative 6. So we get a horizontal line at negative 6. And then it'll graph 4 plus 5x. And there comes 4 plus 5x. And what we want is the left-hand side of our inequality to be larger than, greater than, the right-hand side of our inequality. So if we could figure out where this intersection is, then we could see that to the left, the line negative 6 is always above, or the y value on that line is greater than what we have on 4 plus 5x. At the intersection, they're exactly equal. To the right, it changes. That's where the right-hand side would be larger. So we're interested in things to the left of that intersection. So if we press second and calc, we'll get into the calculate menu. We can choose option 5. And first curve, it's telling us that we're currently on negative 6. That's definitely one of the two curves we're interested in, so I'll press enter. Second curve, it moved to 4 plus 5x, which is the other side of our inequality. So that is the other curve we want, so I'll press enter. And then for the guess, I'll use the cursor key and work my way down approximately to where that intersection lies. And that's about right, so I'll press enter. And the intersection occurs when x is negative 2, and that's what we're most interested in. So when x is less than negative 2, that is to the left of negative 2, this inequality would be true. All right, we don't want x exactly equal to negative 2 because that would make the two sides of the inequality equal to each other. And that would be correct if we had a greater than or equal to sign. But since we only have the greater than sign, as we look at it, we want negative 6 to be above. And that is going to be when x is less than negative 2. You can try that on paper as well and see if you come up with the same answer. Another way to do the same thing, and we'll do this again with example 1, is to actually put the entire inequality into a graph. If I press the y equals button again, I'm going to go down and clear out y2 because I don't need that anymore. And I'm going to go back up to y1, and I'm going to cursor over to the left. Excuse me, I'm going to cursor over to the right, about where that greater than sign would be. And what I want to do here for y1 is I want to put in the entire inequality. So I want to put in negative 6 is greater than 4 plus 5x. So to get the greater than symbol, I press the second key and the math key. That takes us into the test menu, and that's where we'll find the greater than symbol. It's option 3, so I will choose 3. And then I'll type in 4 plus 5x, and I'll press enter. All right, and I'm going to zoom to the standard window. So I'm going to zoom to 6, and it's going to graph. And what we'll do is we'll get a graph that is always going to take on value either 0 or 1 in terms of its y value for different x values. And the same as we saw before, a 1 is going to mean that the expression is true, in this case the entire inequality. A 0 is going to mean that it's not true. All right, so we can see to the left here, and it looks like roughly to the left of -2, we get a 1. That's where it's true. If we want to zoom in and see this a little bit more closely, we can press the window button and adjust our Y range. All right, I'm going to set Y min at -1 because we only need to see as far as 0 in this case. I'm going to set Y max at +2 because we only really need to see as high as 1, but to make sure that those things are clear. And then I'll regraph. And here we're coming in. This is graphing, again, the truth of -6 greater than 4 plus 5x for the various values of x that we see on the screen here. So we see that it's true when x is -10 and -9.5 and -3 1/3 and all the different values we can see here all the way up until we get to -2. All right. If we want to see exactly what's going on at around -2, we can press the trace button. And the trace button starts us off at 0 and 0. And when you're in the trace mode, you can press the left and the right keys and move around on your graph, and it'll give you x values and y values. But you'll notice it doesn't give you very nice x values. There are some ways, and we'll discuss later how to get some better x values. But in this case, we know that we're interested in roughly -2. So what we can do while we're in this mode is we can just type in -2. We can press enter, and it'll take us there. And it tells us that when x is exactly -2, it is false. That is, this expression is false. Now if I use the trace key and just move once to the left, I immediately jump up to the positive. All right, and that helps to confirm our answer of x is less than -2. It's not equal to -2, that doesn't work. But numbers to the left of, that is less than -2, do work. You can also look at this information in the table mode. And what we need to do if we're going to use the table mode is we need to set up our table first. So we're going to press the second key and the window key, which says table set above it in the same color as your second key. And what we have here is table start. What value do we want to have our table start at? And I'm going to say that we want it to start at -2.5, a little bit to the left of the -2 that we're so interested in so far. I'm going to press enter. And then this triangle and table is delta table. How much do you want the calculator to change the values by? How much do you want it to add as it works up and creates a table? I'm going to tell it to do this by tenths. So I'm going to press 0.1 and I press enter. And we'll leave the auto and the ask options alone for now. If yours aren't both set to auto, highlight them, press enter, and make sure they're both set to auto before we actually go and view the table. Once we're set up, we're going to press second and the graph key, which says table above it in the same color as your second key. And here we're going to get some x values starting at -2.5 and then adding 0.1 each time. And what we can see happens here is it's true for -2.5. Our expression is true for -2.4 up through -2.1. But when we get to -2, it suddenly isn't true anymore because it's not true for exactly equal to -2, only for values less than -2. So here's yet another way of taking a look at what's going on here. All right, let's take a look at example 2. And I'm going to choose to look at these things in one mode from here on out. And that's going to be the graphing mode where we graph the entire inequality at once. So it's graphing either zeros or ones. What we have here in example 2 is an or. We're told that x plus 1 is greater than 2 or x minus 1 is less than -2. So we're interested in values of x that make one or the other true. That's what the or tells us. So let's go to the y equals menu and let's clear out what we have here in y1. And let's start by typing in x plus 1 is greater than 2. To get that greater than symbol, we need to press the second key and the math key to get to the test menu. And we'll choose option 3 in this case for greater than 2. And then we need to put an or in here. Well, we also get that in the test menu. So we're going to press second and math again. And you'll see here at the top there are two different menus. There's a test menu and there's also a logic menu. If we press the right cursor key, we'll move over to the logic menu and we can press option 2 to get an OR. Now we're going to type in x minus 1 is less than negative 2. So we type x minus 1. To get the less than, we're going to press second in math to get to the test menu. Option 5, and then negative 2. And we'll press enter. And then I'm going to use the same window I used last time. I'm not going to change anything. We zoomed in so we could see the zeros and the ones really well. So I'm just going to press graph. And here we're graphing it. And right now we're finding values for which the expression is true. Then it stops. There's a little bit of a gap where we found some values of x for which neither of the two inequalities are true. And then we pick up again on the other side. If we want to get a rough idea of what's going on here, we can choose the trace function. And we can move to the right a few clicks here. And it looks like when we move past x equal to 1, suddenly it's true. And if we move our way back to the left through a lot of these zero values, we can see x is getting closer to negative 1. And when we go past negative 1, we also get to 1. So it looks like our graph is stopping at negative 1, leaving a gap, and starting up at positive 1 again. And if you go through and solve these two things and kind of rearrange things, you'll find out that this is really saying that x is less than negative 1 or x is greater than 1. And that's exactly what our graph shows. Example 3 involves an and it's going to be very similar to example 2, at least in terms of the way that we enter it into the calculator. So let's go back to the y equals menu, and let's clear out y1. And now let's type in exactly the expression we have here. So we're going to start with x minus 4. So x minus 4. And that's going to be less than or equal to 1. We go into the test menu, second in math, to get the less than or equal to. That's option 6. And then we type in 1. So there's the first inequality. X minus 4 is less than or equal to 1. Then we're going to press second in math, go into the test menu again. But this time we're going to cursor over to get to that logic menu. And we're going to choose option 1, the and. Now we just need to enter x plus 3 is greater than 2. So we type in x plus 3. We go into the test menu, choose option 3 for greater than, and we choose option 2. Now what we're looking for here are values of x that make both inequalities true at the same time. And the calculator will figure that out for us. So if I press graph, again not changing that window because I like it pretty well, what we see is we're picking up here, it looks like around negative 1 we start. And it was graphing over, and it looks like it stops at about, let's see, 1, 2, 3, 4, and about 5. All right, we can use the trace key to try to see if that's approximately correct anyway. So I'll press trace, and then cursor back here to the left, getting closer to negative 1. And when I finally go past negative 1, it's false. So it looks like this starts at negative 1. If we want to see if negative 1 is exactly part of it, we can type in negative 1. Because we do have a less than or equal to symbol here, so one of our endpoints will be included. When x is negative 1, we're false or 0, so that endpoint is not included. That implies it's the other endpoint. So let's jump down there. We think it's 5, so I'm just going to press 5 and enter to jump down there. And it looks like we're right at the end, and it is still true. If I just move with the cursor key 1 to the right, I fall off there and I'm no longer true. So it looks like negative 1 is less than x is less than or equal to 5 would be a solution to this problem. And if you go through and work this out by hand symbolically, that is exactly what you should come up with. Notice that working with these things is still a little tricky because of the way the endpoints work, because of the difference between less than and less than or equal to, or conversely greater than or equal to. So the calculator can help us with these things, and it still doesn't give us the answer directly, so please be careful when you're working with it. Two more examples I'd like to look at. One involves a quadratic, here in example 4, and the other one involves a rational expression. You've probably never dealt with inequalities that look quite like these before. You may have, but a lot of students haven't when they first come to this course. And therefore the calculator can be very helpful when we're trying to evaluate these things. All right, so let's take a look at example 4. Let's go to the y equals menu. Let's clear out example 3, and let's type in exactly what we see. So we're going to type in a left parenthesis, 2, and then x minus 4, and we'll close the parentheses. Then we'll open up another left parenthesis, and we'll enter x plus 2, close that parenthesis, and then we're going to say greater than or equal to 0. So we're going to press second and math, and we're going to choose option 4, greater than or equal to, and type in 0. And I'm going to press enter, and I'm going to press graph. We're already set up with that nice y window, and we're looking at x's from -10 to +10, so that's a good window to start with. If you're ever uncertain if you're seeing everything, you can always keep the y min and the y max the same, but make the x range larger. Go with a more negative x min or a more positive x max to make sure that you're seeing all the different gaps in all the different sections. Now for this example here, it looks like we've got a gap from about -2 up to +2. All right. Now this is a greater than or equal to. So let's see what happens if I look exactly at -2. So I need to press the trace key first, and I'm going to choose -2. I'm going to press enter, and -2 does satisfy the inequality. We are true there, and it looks like we're right at the edge. If I press 1 to the right, we fall off and we're false. So x is less than or equal to -2 is part of the answer. Now let's try +2 on the other side. And we're true at +2, and it also looks like we're right on the edge. If I press 1 to the left, I fall right off and I'm false. So it looks like x is greater than or equal to +2 is also part of the answer. So in this case, we're looking at x is less than or equal to -2, or x is greater than or equal to +2. If you wanted to graph the two sides of this inequality, you could graph 2x minus 4 times x plus 2 in y1. You could graph 0 in y2, and you could look for all of the places where the left-hand side is above the right-hand side when we're looking at the two graphs, and you could also look for the point of intersection because of the equal to sign. So that's a different way of looking at it. And of course there's also the table as well. Finally, let's take a look at example 5. So let's go back to y equals. Let's clear out what we've got. And let's recognize that since this is a rational expression, we're going to have to put numerator and denominator each in their own set of parentheses to enforce order of operations. So I'm going to start with a left parenthesis and type in 2x minus 3, close with a right parenthesis, divided by, the denominator is going to be a left parenthesis opened, x plus 1. We're going to close with a right parenthesis. And then I need greater than or equal to, so that's in the test menu. And that is option number 4 in the test menu. And then that was greater than or equal to 4. So there, once again, is the inequality written exactly as we see it here with some extra parentheses to make sure the calculator does order of operations in the way we intend. So I'll press enter, and I'll press graph. And we're not getting anything to begin with, so it looks like we're getting zeros. And then it looks like we start to pick up something around -3 or -4. We'll have to take a little bit of a look and see where that's at. It looks like we go about as far as -1, and then we don't get anything else. All right. So let's see where we're at. Let's press the trace key, and let's try -4. Enter. And at -4, we're false. So if we move the cursor key once to the right, we're still false. Move it a little bit further, and then all of a sudden we're at true, but we're kind of somewhere in between 3 and 4, -3 and -4 that is. At -3.6 we're false, at -3.4 we're true. So maybe -3.5 is the edge there. So let's try -3.5 and press enter. And that seems to work. We're right on the edge. If I move once to the left, I fall off. Move once back to the right, I'm back on top. So it looks like -3.5 is our left edge, and that is an equal to, since we have y equal to 1 there. All right, now let's look at the other end. It looks like it's -1, so I'll type in -1 and press enter. And I get y equal to nothing. It doesn't give me a y value. That's kind of interesting. But if we look at our expression here, our inequality, -1 will make the bottom of the left-hand side 0. And dividing by 0 is undefined. So what that says is that the left-hand side isn't even defined when x is -1, so we can't consider it. So what happens if we move just a little bit to the left of -1? Well, we pop up here and we're true. So it looks like, based on what we have here, that our solution might look something like -3/2 or -3.5, excuse me. -3.5 is less than or equal to x is less than -1. If you don't like decimals, want to use fractions, we could say -7/2 is less than or equal to x is less than 1. And you could test that out with the methods in the book. We're not going to be really concerned in this class about you being able to do these quadratic and rational inequalities a lot. You should be able to come up with an approximate answer with the calculator, though. I think that's a good skill to have.